Hello everyone! This is the first video in a series where we will be looking at probabilities. And for the most part, we will be looking at situations about probabilities where we may not be able to actually calculate the probabilities themselves. And in this video, we will start on samples. So I will explain what a sample is, and then we will have a look at how we can find reliable samples, or what constitutes a reliable sample. So what are samples? Now, suppose you want to do an experiment about a large group. Maybe you want to know something about the entire population of a country. For instance, you want to predict what the elections might bring. Or on a slightly smaller scale, maybe you want to know something about all the students in a school. Then it is not possible to ask the entire group for their opinions. So instead, you ask a smaller group and hope that that smaller group is a bit similar to the entire group. And it's this smaller group, this is called the sample. Now, some samples are more useful than others. To do a good experiment, you need reliable samples. What does that mean? It means that your sample has to represent the whole group. You should be able to reach everyone in the group kind of equally. For instance, if you want to know something about the entire school, say you want to know what everyone thinks about the new building, then asking your own class doesn't say very much because you only have 1 year and you only have one level of education. A better idea would be to ask, for instance, the class representatives from each class. Then you have all the different years, you have all the different levels of education. It's still not ideal, of course, because it's still not every student, but it is a better sample than asking only your own class. Now, that's just a general idea. Do I reach everyone? More specifically, what you can think about is, can everyone participate? Well, if you ask only the class representatives, of course, not everyone can participate, but it's still spread fairly evenly. For a different example, consider asking someone whether they have internet access through an online survey. Then the group that you're interested in, maybe the people that do not have internet access, can't fill in the survey, so you can't find them. And yes, this actually happens, that people will do this. So that would be a bad sample. Instead, you could try to call people and randomly call them, maybe from someone from each class again, to ask about the internet access. And you have a better idea and a more general, more spread out sample than if you would try an online survey, which obviously would not be the correct way to do your survey in this case. So that's the first thing. Can everyone participate, and can it be spread? Is it spread somewhat equally? Lastly, last question is, are there people that can answer who shouldn't? For instance, if we go back to the elections, it can be very interesting to ask children what their opinion is, but it's not a good predictor of the elections because, well, they are not able to actually vote in those elections. And if you want to know something from all the students, then it shouldn't be possible for the teachers to fill it in. So you can't just leave surveys somewhere and wait for people to fill it in because you don't know who fills it in. Now, there are ways to make bad sample better, but this is quite difficult and requires a lot of mathematics, a lot of research into what actual sample you had. So the best first start of an experiment is to have a good, reliable sample where you have good representation, all the relevant groups can participate, and people that are not relevant to your research can't participate. So these are 3 things to think about. And in the exercises, you're going to see more examples where you have to decide whether the sample is reliable. Good luck.